Hello everyone. Today we'll talk about the main security vulnerabilities and features of Aptos and Sui. Those two blockchains are relatively new and they have a lot of new features improving on Ethereum and attempting to make blockchains faster and more performant. And basically, when we look at a Sui or Aptos application, those are the three main points we're going to research. Besides what we already do on Ethereum, these are very different on Aptos and Sui. Throughout the presentation, I'm going to be using some terms that are more proper for Aptos than the Sui blockchain, but they all have equivalents on Sui. So if you have any doubts, we can chat on the comments and I'll explain the differences for you all. Basically, there are three things. So resource model. On Ethereum, we have a global state. So the blockchain has a single state that is being mutated by every transaction. On Sui, we don't. Here we have a lot of different resources that are mutated by different contracts and that do not interact with each other. We have formal verification. This is a way to verify contracts in a mathematical fashion. So instead of just testing if the contract works or not, you can check if they have some properties, like if it is possible to mint an NFT without paying, if it is possible to have a balance greater than some value, so some more mathematical kinds of proofs of rightness. And finally, parallel execution. Essentially here, we're going to check if the contract implements correctly the technology behind Aptos and Sui to leverage all the parallel engine that you can use and make transactions faster, cheaper, and more performant as a whole. So let's get to it. Regarding the resource model, essentially, when you look at Ethereum, we have smart contracts that encompass code. So a contract has its code that determines how the contract is executed, and also the storage. So it stores all the data from executions inside of the contract itself. And this is why I call it a global state, because every contract has its own code and storage. Every contract may interact with other contracts during transactions and alter their state as well. So all the state of Ethereum has to be updated one at a time, making it always a sequential execution engine. You cannot execute multiple different transactions in parallel because they are messing with the same state, and you cannot guarantee that the state is being transitioned correctly from the transactions. So that's why it has everything together, and it's called a global state. When you look at Aptos and Sui, their main innovation is that they broke the state into different parts. So a contract is in an account that only has code, and that account is able to create storage into different accounts, so into user accounts, and store data in them. This data is called a resource because it's unique and you can transfer it and you can never delete it. It's all transferable. It belongs to an account. What's important here is that this is not only a technology that makes the blockchain more scalable, but it also changes the fundamental assumptions about how it works. So if you look at Sui and Aptos, we can't really design our application the same way as we do in Ethereum. So this is something we look at a lot. People are used to Ethereum and they base a lot of their contracts on Ethereum contracts, so that they try to bring the code from Solidity into Move. And when they do it, they make a lot of mistakes. One of the most common is regarding permissioning. In Ethereum, it's very common to have an owner and guardians in the contract that have permissions. So usually you store their account addresses into the contract, and then you verify that the account that's interacting with them is of the data address. That can work in Aptos and Sui as well, but it's not regarded as a best practice. It may lead to a lot of different errors and a lot of execution problems that minimize the benefits of the blockchain. What we have to do here is create a specific resource. There's a permission. So you create a resource that gives someone the permission to interact with the contract, and you pass that resource into functions. So you have to think about the application in a different way. And this is something we look at a lot. Has the contract from the client been just transplanted from Solidity, or has it been thought out and built for the Sui or for the Aptos blockchain? Because the architecture, the design patterns are very different, and you should understand them in depth. The second important point is formal verification. On traditional computer science and traditional application development, we do a lot of testing. A test is essentially when you execute the code that you're developing and you check that the state of the program is as expected. So you're using a mint function in a smart contract for a token, for instance, and you're checking to mint the correct amount of tokens, that it is below the maximum that you can mint, and also that you cannot double spend or anything else. So you test things, and by testing, you figure that the program works or not. The problem with testing is that you can never test all of the hypotheses for execution, because there are a lot of different things that can happen during the production and during the blockchain's life, and you cannot test for all of them. But there must be a way to guarantee that some things can never happen in your contract. And this is formal verification. Formal verification is a way to mathematically prove something about your program. You can prove, for instance, that certain variable, let's say the maximum amount of tokens, will never overflow 10,000. And you don't need to prove every single situation, a general proof, kind of a mathematical proof, that the system can never produce a value that's greater than 10,000. If you do that, you get a lot more certainty about how the contract works. This exists in Ethereum, for instance. It exists in a lot of languages, but it's usually very expensive and very hard to implement. There are a lot of consultancies and firms specialized into it that employ a lot of PhD people, a lot of people with a lot of knowledge on mathematics and on how to do formal verification. And it's very hard. The good news is that Move and Aptos and Sui by default also have formal verification as a tool, but it works in a very intuitive way. You can write them directly into the code and they're integrated with the language. So it makes it easy to use. It's not the simplest thing to use, but it's relatively easy and it gives a lot of security in your smart contract. So it's always important to do formal verification. If you haven't done it, we're probably going to use it into the tests to try to figure some things out. And this is more of a tip for developers, but if you're developing an application that's supposed to hold a lot of funds or user critical information, you have to do formal verification. It's a way to make sure you're secure, and it's not that expensive here. You can use it in one test in formal verification is probably better than 10,000 tests that are trying to check for the same thing in a regular framework. So you always check for formal verification as well. The last important point is parallel execution. I mentioned a lot that Aptos and Sui have an engine that allows them to process transactions in parallel, that makes them faster, cheaper, and more efficient than Ethereum. That's their differential as a blockchain. But that comes with costs. You can't really just implement that on top of the traditional EVM. You have to build your entire logic differently. And that's why you have resources on accounts instead of a global state. And here we are coming back to the point of design patterns. Traditional design patterns that you use in Ethereum do not work well in Sui and Aptos. Why? Because they are not meant to be parallelizable. So we have to design things differently. Essentially, in Aptos and Sui, we have a contract account that has the code. We have a main account that is used to initialize the contract and generate its central state. And we have the peripheral state that's stored in the user's accounts. What happens is, whenever you call a function into the contract, you're going to have to use the state from one of those places. So essentially, the less state you have on main, the best, because when you call a function, let's say this is a token, and the token stores the balances into the account. So the balances are stored into the accounts, and they only have metadata here. I want to transfer a token from user 1 to user 2. I only need to fetch the state from user 1 and user 2, and I do not need the state from main. That means that this token can be transferred by a lot of different people, a million people at the same time in parallel, because they are not having to nestle the same state. But if I have, let's say, some data here about total supply or something like that, and I want to mint new tokens, I can't do that in parallel. That's going to be sequential because only one transaction can alter the state of main at a time. The design pattern here is you always have to break your data into some smaller parts and ideally distribute those parts between all of the users and not in the main part of the contract. The more data you have on the user, the faster, the cheaper, and the more efficient your transactions are going to be. The more data is stored on main, the more it's going to look like a traditional Ethereum contract. So all the design patterns from Ethereum are going to put the data into main. So don't follow them. You have to follow the Move design patterns that are going to spread the state between the users and allow you to have a more efficient execution of the code. This also means that something that you would traditionally use as a single contract in Ethereum, you should also think about using different versions of the same contract on different initializations. That's also going to help you parallelize transactions more. So let's say we're talking about AMM or some kind of DeFi application. You probably should separate the different pools into different initialized contracts because that's going to make everything run in parallel. So that's essentially the thing about parallel execution. You have to ensure that your code allows Move and Aptos and Sui to do their magic. You cannot use just Ethereum design patterns. You have to use the specific design patterns for the blockchains. And those are the main points into Aptos and Sui. If you guys have any questions, we're happy to help you guys on the comments here. You can also reach out to our website. And also feel free to ask different questions, suggest new topics. We're always making new content. and we will be glad to explain different things to you as well. Thank you for watching.